Welcome everyone. Thanks for joining us today in our first webinar. My name is Rosa from Lima, Peru. Today we're going to talk about DevOps and what is it. But first you will wonder what exactly is Octana. Octana specializes in custom design and development. Our mission is to enable companies to understand and leverage Salesforce technologies to deliver the best customer experience. But to understand more about DevOps, we have a special guest, Sebastián Vera. Welcome, Sebastián.
Well, hi everybody, and welcome. Thank you, Rosa. Well, my name is Sebastian, and I have been working with Octana for about a year, mostly as a release manager, but with mentioning that I'm also a Salesforce certified application architect. So for those who knows a little bit about DevOps, well, I come from the developer side. So what can I say? I really love this work from the one designing development life cycles that actually improve development capabilities has been what I enjoyed most. For me, helping devs and the whole team to work as comfortably as possible is bringing me great satisfaction. So I'm really happy that you're here and hope you like this webinar as much as I do. And well, love to motivate you and other projects to jump into this practice. So, well, being that said, Rosa, I think that we can start.
Yes, but before to start, just to add that if you have any question, don't worry, because at the end of the session, we will have some time to resolve all your questions. So don't worry. So now let's start.
Thank you. Well, I'm going to try to explain a little bit what is DevOps as best as I can, and we're going to cover its goals, and hopefully you will get an idea of why do we need DevOps, and lastly, we'll be covering one of the frameworks that is used in DevOps. Particularly today, we're going to talk about continuous integration. So we're going to focus more on the automation side of DevOps. And as mentioned, as Rosa mentioned, we will have a question and answer section. So take your notes and write all your questions that I will try to answer the best as my ability. So let's go. So the question is, what is DevOps exactly? It must be more than a fancy word to use in the looking for talent skill section and in that client integration process for these new startups. It sounds like it means something. Well, first of all, it comes from the words of the junction of the words developers and operations, which are two different teams on IT, and that they're normally set apart. One take care of the build process, and the other one's about maintenance. When we say developer team, we're not only talking about developers. We must include lead developers, tech leads, architects, and quality assurance team as well. When we say operations team, we are talking about sysadmins, source code management engineers, DBAs, network engineers, server engineers, basically all the ones responsible for deploying the application and maintaining the servers and databases and monitoring logs and traffic as well. So having that clarification made, DevOps movement started around 2006 as a response of the culture of fear that the industry generated. The Agile perspective was great at solving the issue between the requirements and the build part, but there was something lacking. The industry of software was still dysfunctional. So DevOps came slowly. It's actually a framework, a way of working and doing things, and simply a totally different mindset. So as a framework, it's supposed to have a series of preconditions, activities, process, tools that they are all designed to solve, or at least to prevent a particular problem. The thing is that we don't do something because it's just fun to do, right? So the question is, what are the changes and the problems that it tries to solve or it is to avoid? Well, we all know how the story goes with software. We all had seen it and we all had suffered from it. Production rolling back on incompatible changes, delayed releases, and delays on going live to market. And what is worse, total burnout. Teams getting demotivated by working many hours fixing issue through issue just to get the release out of the door. The operations team ended up having complex deploying sessions that usually are time consuming and with many manual steps. So this ended up causing that the lesser environments, but are actually the daily working environments, get infrequent updates. The more time that passes between each update, the more those environments tend to diverge from each other. So as a consequence, those discrepancies between each environment will impact the developers in a way that the new features will become harder to be developed. All of this fragility created a culture of fear and long approval process. The new code is handled by many people acting as approvers and reviewers, and not only analyzed by tools that look for unspotted defect on the source code. In a few words, it starts to become hard to get something out to production. Release schedules are being more spaced between each other. Since the operations team cannot handle higher frequencies, the situation gets even worse. This is known as the downward spiral. It starts slowly and you don't realize. But you will see the step backs in the big picture. We notice that production code deployments are taking longer to complete, and it starts to become more problematic. We start relying more on the firefighters than on our daily work. The number of customers impacted by outage increases. Then we are no longer able to respond quickly. We just struggle to provide a stable and reliable service to our customers. So what is this framework all about, and how can it help to solve some of the naming problems? Well, the thing is that we try to break that abstract line that separated the two teams from each other so they can work more as a unique team. They need to share responsibilities. The delivery cannot be a two-step process where the developers does the code to the operation teams and they toss it back because it fails. They must collaborate from the beginning, helping each other. Some of the tools will come into place like automation, source code management, will have a slightly different role in order to make this process repeatable and consistent. And of course, all of this to achieve one common goal that is a successful delivery. But where do we start? Well, yeah, the answer is pretty obvious. By solving these problems, DevOps enables us to simultaneously improve organizational performance and improve human condition. So all of this philosophy sounds great, you'll say, almost like a fairy tale. But how do we actually do it? How do we solve these problems? Well, there are many things that you need to do actually. First, we need to think on end-to-end responsibility. The delivery is a team responsibility. It works on my machine is no longer a bridal statement. The developers team and the operations teams will take ownership together of the new features. So both teams will be responsible of its delivery. They will have to work together. Operations teams will know the details of each implementation. So any dependency like data configurations, script, or whatever needs to be outlined and shared earlier to the team. This let the operations team stay tuned and prepare for the incoming changes. Operations teams could prepare scripts to allow developers to work comfortably on their environments. For example, automatic deployment scripts, automatic test data loads, environment management scripts for cleaning and cloning. So to put it in a way, they must serve each other. If for any reason there's manual configuration that needs to be done, the whole team will be responsible for the documents needed to make sure that a piece of code can be deployed to any given environment. We normally call these documents deployment activities or deployment steps. If you are using GitHub or you're working with a pull request approach, the pull request description can be an excellent place for holding that kind of documents. If not, another way could be creating a wiki page or a collaborative shared document to link the individual commits messages. Or if you're using a Scrum board then you can have a dedicated section for this. The quality assurance team will also have a primary role here. It will be the first persons to receive a finished piece of code. So it's a great moment to test the scripts and correct any misleading deployment activity. Small increments over monolithic deliveries. It is not easy for a big chunk of features to fit on a running server without any errors. It just doesn't happen. Deliveries should be more often and with less density. This means less features. Ideally, we want just one small functional change to be delivered, so we can do it several times during a given period of time, which normally was targeted as a unique delivery. Let's put it this way. Imagine you have this open source and free writing tool that crashes once in a while, and you're working on your final grade thesis. Yes, you're probably not the best or the most clever person in the world, but that's a whole nother topic, so stick here with me. You soon realize that you normally save your work when you finish a chapter, that is every 2 weeks. But this crashes happens once a month. So when it happens, you lose almost 2 weeks of work in the worst case. So you start saving more often. Eventually, you end up saving after you finish a paragraph. So in the worst case scenario, you lose one paragraph. This way, you end up having a safer and systematic solution. The same applies to software. If for any reason you need to roll back, you will just lose the last change and not the full release. So we're going to automate everything. That way we can easily replicate it over and over again. This means that we must reduce manual procedures as much as we can. This is where the operations team can help us more, defining configuration script, data script that can be bound to the source code. So whenever there's an environment that needs an update, this script will do the preparation and post setup work. Sometimes it's not going to be possible. It is okay, but the less manual configuration, the better. Sometimes happens that the manual configuration is easier and faster than the scripts. For example, log into an environment and select this option from the settings menu is easier than creating a script, finding and writing the appropriate code that actually performs that action, and finally testing it. We would be tempted to do the easiest way. So imagine this procedure needs to be done on every deployment since the configuration is lost each time we deploy. Imagine to do this procedure on each server, on each environment. After 10 times, the scripts will seem the easiest way. Or worst, imagine that it is a multi-step process. There's a big chance that after several times, one configuration may have been done wrong, so we introduce an error. That is the main reason for automation. We do it once and we check that it works as expected, then it should behave the same way every time we repeat the process. And lastly, we're going to run the unit test. And hell yeah, we're going to do it. Unit tests are the loved or hated aspect of programming. Developers tend to hate it. We sometimes don't see the value of creating so many tests, especially those that test the obvious. It feels almost like losing time. Also, unit tests are the part that we forget when we estimate a task. Like, well, yeah, it's an easy task. It's just a few lines of code. It will be, I think that it's too story part for the estimate. And then when you start writing it, you realize that you could actually unit test it. And when you dive into, well, it's like so many tests actually you need to write. So, and of course, that task is no longer true anymore. So, like I said, it's a love it or hate it. But the thing is that you should love it because it will have a major relevance on the DevOps process. The thing is that unit tests are the key of a delivery reliability, and especially those that look like testing the obvious, because those things that are so obvious, we don't pay too much attention to them. They are so obvious that they don't deserve our attention. You write that code or do that configuration, you check that on the UI, it works. You commit, then you forget. The thing is that a few months later, there's a background protection. Their users are not seeing the button that even though they have all the right permissions, later, after debugging a lot, we see that this code was overwritten on a merge conflict. So we introduced the error without knowing it. But if you have written the obvious test, that bug would not have been find its way to production. Lesson learned. All the tests that we can write are important, and they deserve the rights to be on our application. But yeah, tests are boring. Because for running them, you need to open the IDE, to pull the code, run the test, and you will find that there are many ones that are failing because you missed that configuration. So you just don't run them. Now, imagine that there's a robot, call it Billy the robot, that works all day, all night, without rest, on every single change you make to your application. He runs all the tests in a dedicated environment that is fully configured. When he finds one error, he will let you know that you cannot proceed with that change. And if everything goes right, he will deploy that change. Wouldn't it be awesome? He will do all the heavy lifting and you go to bed earlier. Well, if you have the correct set of unit tests, you just need to build the robot. So since DevOps people are serious people, they don't like calling it build the robot. They decided to go for a different and more fancy name. They call it continuous integration. So continuous integration is a practice where developers integrate working code, preferably several times a day. Each integration then can be verified by automated tests. This is a good and concrete definition. It resumes pretty well the work that Billy the robot does. So let's take a closer look. The word integrates comes from the process of adding the new changes that we were talking about. Then talks about working code. Working code is the code that passes the test. So if they don't pass the test, it's not working code, so it cannot be integrated. It has a frequency concept, so it says several times a day. So here showing the small changes over monolithic deliveries that we mentioned before. Only small changes can be done several times a day. There is one extra thing that it had not mentioned. Each integration can then be verified. This means that there's a history of these logs going on. This traceability aspect is very important since it can help to track issues and find the exact turning points where these defects emerge. And then it just ends up by mentioning testing and automation aspects that we also talk about. So far, so good. So let's jump into the goals. First, easily detect integration bugs. Sometimes tests that are passing on our environments won't be passing on another environment. And this is the point that we're trying to catch. Despite of the astonishing look of our faces when this happens, it's actually a good thing. It points out that there's a divergency between environments that we need to address. This helps us to have our environments more in sync and, of course, keep our application strong. Keep in mind that the more updated tests that you have, the stronger the application you build. This is actually a very important statement. There are development practices like test-driven development that are based on this principle. Furthermore, they point to writing tests before the code is developed. Those practices are considered the most reliable way of programming, which means they're less prone to defect, and also are considered the ones that achieve the highest development velocity. Despite the general belief that writing tests slows the developers down, it's actually the other way around, because we lose more time trying to find the source of a defect than the time we lose writing a unit test. I don't want to derail on this, but this is actually an example of how compatible DevOps is with other software engineering best practices. Second, increased code coverage. Code coverage has been used as a metric of how reliable the unit tests are. It is based on a simple concept. If after a test run we have uncovered source code, there are corners in our application that we are uncertain of their correctness. Therefore, they could be unspotted defects. There are platforms like Salesforce that won't let you deploy code that has not reached a given amount of code coverage, helping in that way the work of introducing best practices. Develop faster and never ship broken code. Today, organizations adopting DevOps practices often deploy changes hundreds of times per day. In an age where competitive advantage requires fast time to market, organizations that are still driven by the old-fashioned practice are doomed to fail. There are two major points that make a big impact on development velocity. One of them is hands-off, so deployment can take place. Having to rely on other teams will only make us slower, because those teams won't be prepared and will have to catch up with their task. Then imagine if we have a multiple environment that form a sequence of approvals, like QA's approvals, product owners approvals, business approvals, security approvals. And they all need the code to be deployed to each environment so they can start their work. The velocity will drop considerably, and we will lose momentum. The other thing is debugging. When unexpected errors occur and we don't have a clue where they come from, fixing and debugging it can take many hours or even days. We know that having unit tests does not guarantee a defect-free application, but it helps a lot on identifying where these issues come from. And what is the most important, if we're using a continuous integration framework, we can catch them on a very early stage. So fixing them is much more faster. And of course, we'll promote working code. Consistency in the build process. Continuous integration results in a more streamlined software development process. It increases consistency, reduces the risk of major errors during development stage, and will let us rely on automated frameworks that will be able to repeat the process over and over again. This consistency is achieved by the reduction of manual procedures and hands-off. Increasing confidence in software. Continuous integration is the result of decades of experience and provides value by helping to increase the ability to deliver faster and valuable systems to users. It helps producing higher quality code base with fewer defects. The severity and frequency of the defects drops after adopting continuous integration. This provides assurance that the production deployments will run a lot smoother by identifying incompatible aspects earlier on the chain. And this is crucial. So far, we have seen the importance of devs working with ops more closely, the importance of the good set of unit tests, and how automation uses that unit test to validate a new piece of code, and the AutoCAD scripts of the devs and ops that allows the automated deployment. We just need to hook them up to create a continuous process. So each new piece of code will follow the same process: build, test, then deploy. For a starting point, this has been a lot to take in and very theoretically, actually. So why don't we go and take all this to ground? So let's put this in a flowchart so we can picture all what we have discussed so far. So let's imagine that we have this incredible team where devs and ops work together in the same side with the same goals. Frank is one of the devs and is working on a new feature. He's ramping up some work, and he finds that there are some configurations that will need to be done on the environment before this code is deployed. He calls Steve, the DevOps guy, so they can work together and create one script that does the configuration before the code is deployed. Steve adds some configuration scripts and binds them to the source code. Soon they start pushing to the repo so Billy the robot can start testing the implementation. Billy the robot discovers the new commits on the repo and starts a series of automations process. This process is called deployment pipeline, and it will be a topic for our next webinar. But so far, we need to know that we will trigger a deployment pipeline whenever there's a new commit. When the process starts, Billy the robot finds that the configuration script by Sid created. He builds a temporary environment and executes the scripts. Later, he deploys the source code with Frank's changes, and after deployment is exceeded, he will run the unit test. After a few minutes, Billy finds that one failing test and reports the results back to Frank. Frank corrects the error and pushes new changes. So as you could expect, the deployment pipeline is triggered again. By now, all tests are passing, so Billy the robot continues the deployment pipeline by deploying the changes to another environment. In this case, Mike's environment. Mike is a QA member and starts testing the feature. But he finds out that there's a feature that is not displaying correctly on the user interface. Mike reports the incident to Frank so he can fix the issue. After another trigger of our deployment pipeline, and of course, having passed all the tests, Mike's validate the feature. So Billy the robot triggers the last deployment pipeline that brings the code to our production environment. Hopefully, this was clear enough of how this framework can be set up. And hopefully, you can see how fast this flow can be. I know this production deployment will get some questions and concerns, but we will take a special focus on our next webinar. Well, I'm going to be trying to focus on continuous delivery. That is like the next stage. So I hope you have enjoyed our time together and I hope you are not sleeping right now on the keyboard. So thank you very much for attending and for your great support. So I think, Rosa, that we can go for the question and answer section.
Yes, thanks, Sebastian. Thanks for all the great content. I think now it's much clearer what is DevOps and how it works. But if you have any question, please just send them in the chat. And while you send your questions, please you can say the next slide, please. While you send your questions, if you're interested in looking for new opportunities, you can check our career page. We are always looking for new talent. Currently, we have offices across Ecuador, Paraguay, Peru, Uruguay, and West Virginia. So if you're interested, just check our website and apply. So now I think we can start the round of questions and answers. Let me see what we have. Wait a second. Okay, so which are the top DevOps tools?
Well, there are actually many tools that they can use. The most used ones, of course, repositories are the main point of action. And then we have different automation tools that are based on continuous integration approach that, for example, Jenkins, Azure, the DevOps, there are many ones that will listen to our repository and will let us define a script that will run all of these automation process, right? So mainly this Jenkins tools is an open source tool. And then there's many others like that are integrated with Salesforce. For example, Circle CI, Cumulus CI, but the first ones that came into place was Jenkins.
Great. We have another question from Andrea. She says, what DevOps tools have you come across? Do you recommend for Salesforce related products?
Yeah, well, my first tool that I used was, it was Cumulus CI. It was actually a great tool. It will let you use Scratchworks, and then you can spin up Scratchworks and deploy all the source code. And actually, my experience with Cumulus CI was actually great. They also have a defined, like would be a pipeline that is actually a script, a YAML script that will let you define how good you want to be that deployment to be. Like, for example, if you want to add test data, or if you want, I don't know, to run specifically one Apex class before the deployment or after the deployment, right? So it's really, really, you can customize the way that you are going to be deploying, not just deploy this. You can just deploy chunks, for example, deploy this folder, and then deploy the whole source code, or just the delta changes, right? There's many functionals that actually work great. They also have one feature that that I think is really great. If you're working with GitHub and you're using the master and feature branching strategy, it will let update all the different branches when there's a new commit on the master branch, right? So if, for example, you merge one branch, all the other branches will get that code deployed to their organization. So it's actually a really, really great tool. Jenkins has been the second one that I have been using, and it's the one that I'm using actually right now. Jenkins is one of the standards tools that you use for DevOps and continuous integration and also continuous delivery. It's open source, so there's a lot of plugins in there, and there's a lot of integration with different other tools, like, for example, Slack, for example, well, GitHub, GitLab. There's integrations with Assembler, right? So it's a really, really, really nice tool, and it's open source and it's constantly being upgraded. I heard about CircleCI being a great tool. I actually did not work with it myself, but I heard it's a really great tool for Salesforce. And I had not experienced Gerset, but actually assist a demo from Gerset, and that tool is really actually great for helping Salesforce deployments, right? Because the deployments in Salesforce are really, really troublesome and cumbersome, right? Because there's so many dependencies on the different metadata with the API version changes. And then Gerset has a really, really good way of checking before actually going against the cloud. So when you have that source code, you can compare that with an environment and check if that deployment is going to fail or if it's going to be successful, right? And it will give you a more detailed output of what are the different changes that you need to do, right? Because sometimes when you deploy something to Salesforce, the error message are really not great, right? So Gerset has like done an over implementation over the Salesforce CLI, and they have really great error messages. So you understand what actually is failing.
Great. Then Nicolas said that he missed the last part about the production deployment should be automated too.
Yeah, the idea is we try to automate everything. The thing is about production deployments is that they are more of an issue, and sometimes business doesn't want a tool, an automated tool to do those deployments. But yeah, the main goal of DevOps is try to automate the whole what they call the value stream. The value stream is the process of from starting point from a environment like the developer's environment till you reach the production environment and all the process that you have in between, right? So that is the value stream. It means a stream because it's a stream, and value because you are delivering value, right? So that is the value stream. And then it will help us to identify that you need to automate everything. So you have that value stream is going to be shorter. So yeah, DevOps points to automate all deployments.
Great. Also, Steven asked, did Cumulus continuous integration uses the same Salesforce DX commands?
No, it does not use the same ones. They have like a wrap up that they. I think that for me it's more clear because SFDX commands are more hard to catch, right? Because the way they are written, Cumulus CI gives you commands that actually are more human readable, right? And you could actually create your own commands because you will have a YAML that you can create your own commands, right? So like deploy to production or for this environment, and just try and script that, name that command like that, and you'll have that command. So yeah, it's better on the naming and it's more intuitive.
Great. Also, Santiago asked, from your point of view, how different or similar are the profiles of a DevOps and a developer? In other words, DevOps must go through a stage as a developer before becoming one?
Yeah, it's actually a good question. The thing is that operations teams has had a really different role on IT in the past, and DevOps is not trying to change that, because there's some things that operations team does that needs to be like that. Like, for example, monitoring, right? The DevOps is what it adds is a capability of development to the operations team, right? So if you ask me, you could be on both sides and start from both sides. The thing is that being a DevOps, you will need to know code, and you will have to know how to write and how that works, because pipelines are written in actual code. For example, Jenkins pipelines are written in a Groovy that is actually a version of Java, right? And most of the continuous integration tools are using like shell commands, right? So if you know how to write shell commands, it's actually really good. So most of DevOps engineers will have like a profile oriented more to Git. You must understand Git and know how to work with Git, and more like shell commands and a normal language, like for example Java, and those oriented like that. How that answer the question?
Great. Then we have another question. What should I do if I want to get started in DevOps?
Well, that's actually a deep question, because there's many ways that you can go, and there's a myth that DevOps people, DevOps engineer, are the top-notch senior developers, and that is actually not like that. DevOps actually have a wider spectrum. Of course, there's really great DevOps engineers that they are really awesome, that I also are CTOs, right? And then you have DevOps that are just juniors that they're studying, right? But if you want to be a DevOps engineer, if you like this way of programming, right? You are not interested on specifically designing application, but to help a development life cycle to be developed. You can there's certifications that you can take online. There's one from Amazon that is like the most common one, and there's one from Kubernetes that they are the most top fashion right now. So they're really great. The idea is that we can address that path on the training, so we can eventually have a DevOps path training. But yeah, we're still coming.
Great. Also, we have another one. How is DevOps different from Agile?
Well, the thing is that they complement each other. There's a myth that says that DevOps comes to eradicate Agile, and that is not true, because Agile focus more on the requirements side and the build part, right? And DevOps comes from what comes next, right? It's like an extension of the framework. There's some part of Agile Manifesto that mentions about the small increments part, right? That is the principle of how DevOps works. But DevOps tries to focus on those value streams, how they can reduce it, and how to automate them, right? So it's like the next step on the new era of software engineer. You still need Agile. You still need to work with Agile. You still need to have a Scrum Master, a Product Owner, and have your Scrum ceremonies, right? But how you deliver that to market, well, you will have to choose DevOps.
Great. And I think that's all the questions we have. Thanks everyone for joining us. And thanks, Sebastian, for your time. The
Please, no pleasure.
webinar was great. we will be posting the video on our YouTube channel. So I think we will posting it in a few days, so you can watch it again if you have any question. And also soon we will be launching a new webinar, so stay tuned. Thanks everyone, and see you next time.
Thank you
Bye.
guys.